Hello everyone. Let's understand what is a unitary matrix and why it's important. And if you are working in quantum mechanics, you would have come across this term unitary transformation or unitary matrix are very common in quantum mechanics, signal processing, and sometimes even in particle physics. So if you want to have the formal definition of a unitary matrix, it's easy to find in any textbook. But what it simply means is that if you take the transpose and complex conjugate of a matrix and multiply by itself, you get the identity matrix. So this is the unitary matrix U here, and it actually, in real space, it's called as orthogonal, and it actually acts on a vector. So this process we call it as unitary transformation. And then it preserves something fundamental of that vector. In quantum mechanics, it's actually the probability of that vector. And in signal processing, it actually preserves the energy or information. So then the unitary transformation is the Fourier transform. Fourier transform is also a unitary transformation. And if you want to look it from a philosophical angle, in many Eastern traditions like Hinduism or Buddhism, people say the soul is preserved while the body changes or fades away. In that sense, we can say that soul itself is a unitary transformation because the form evolves but the essence remains the same. So let's say we have the wave function in quantum physics. Psi of t is the wave function at time t, and then what it tells is that it evolves according to Schrödinger's equation. The Schrödinger's equation is itself a unitary matrix that I have written here as u of t here. So that evolution u of t is psi of 0 is the wave function at time 0. And so because u of t is unitary, it preserves the probability, total probability of the quantum state here. And if we look at the Fourier transform, we can write it as f of ij is something like this. And here f of ij is unitary as well. So what it means that if we move signal from time domain to frequency domain or vice versa, we are not going to lose any information. The total energy or the information content is preserved because of this unitary matrix property. So in quantum world, the unitary preserves the probability, where we can find the particle in the quantum space, the probability of finding it somewhere, or in the signal processing or Fourier transform, it preserves the information. So change is fine as long as nothing is lost and something fundamental is preserved. That is unitary transformation for you. And thank you for watching.